I'm Viraj. I'm one of Astronomer's co-founders and field CTO, and I help lead our ecosystem efforts and help make sure that Airflow plays nicely with everything in the modern data stack. And a large part of that is with Snowflake. So thank you for Snowflake for giving us the opportunity.
I'm Stephen. I run the data science team at Astronomer. We're the commercial developer of Airflow, which is how you manage all your data pipelines and your data ecosystem. And not surprisingly, in running the data science team at Astronomer, I use Airflow to do all of our work. It's the foundation for the way that we've built sort of the orchestration of all the data work that we do. And at the foundation, beneath that foundation is Snowflake. So I'm also grateful for being invited here to talk about all the great stuff we're doing.
Awesome. So Stephen, this isn't your first time running a data team, is it?
No. I've been doing it since, well, to be honest, before even the notion of the data scientist was coined by folks like DJ Patil. This is going back, I guess, about sort of 15, 16 years now. So I've definitely worked with many different data science teams, both that I've been running and then sort of working with companies like astronomers, customers, and organizations that have large and small data science teams struggling with the how difficult it is really to get operational analytics up and running and sort of empowering your business and deeply embedded into your business processes. That's really been what I've been focusing on for a while now.
So kind of through all of that, what have been some consistencies that you've run into as a data leader?
Well, as I say, it's kind of a little bit crazy out there. I mean, I think things are slowly convert. Just as I think in sort of the last 20 years, you've seen a convergence in software development around a certain set of core disciplines, agile practices, sort of standard technical stacks. I think you're beginning to see that in the data world, but it's still early, I think. And so I think one thing that's been consistent is the panic in the eyes of a data leader in the morning when they wake up and they're like, I don't know where my data is and how my models are doing. And so just the sense that it's still a little early in terms of corralling together a set of standards around technologies and processes. And, it's still very early for things like ML ops and data ops. Maybe another thing sort of related to that is just coordinating across multiple teams. It's still the case that a great deal of analytics doesn't become operational, doesn't become sort of fully productionized. And if it is, then it tends to be ad hoc for each particular team. There's not a great deal of coordination in terms of standards for model production and reports and statistics and how you operationalize those things. I think it's also true that data scientists are still a little bit of a rare breed of people, and they sort of, they're very focused on coming up with accurate statistics and predictive models, and they want to use whatever technology is available out there to do that. And so they can be, very, very particular about the technologies they use. And that, of course, makes the operational aspect all the more challenging because, you've got to take whatever they've developed off in the lab and somehow make that run in the real world.
I think rare breed and particular is about the nicest way to say picky that I've ever heard.
I wouldn't say that. But yeah, maybe you're right.
Either way, right? So like we are, a self-defined modern orchestration platform. And I think a lot of times it's not exactly clear what an orchestration platform unlocks for a data team. So, what does it give you as our data leader?
Yeah. So as I mentioned, we use Airflow at the heart of our orchestration platform. You can't do orchestration. You can't manage and coordinate data pipelines in production and in development unless you control the scheduling and the workflow management of that. And that is what Airflow is, right? Airflow created by Airbnb some years ago to help them manage a complex ecosystem of data pipelines. So that's at the heart of it. But it's more than that, right? It's how you sort of control access to the data. It's how you deal with failures. It's how you manage job schedulers and Airflow instances when they number into the dozens or even the hundreds, and how you manage, thousands of SQL pipelines that are running at any given time. It's how that you having built sort of a core set of standards and practices, how you share common utilities. It's how you roll that out to the rest of the company and get people who are maybe not part of the core data science team to contribute. And then once you've created that access and created that sort of open ecosystem of data, how then do you sort of get visibility across it? How do you understand what's going wrong, what's going right, what the relationship is and dependencies? That's, I think, what we mean by orchestration, right? It's like, it's not enough just to run data pipelines. It's the organization, it's the coordination of those things.
Yeah. It feels like there's like 30 things to consider there.
Yeah, it's a lot. And I have to say, using Airflow and then the orchestration platform that we've built, Astro, that's Astronomer's platform. Honestly, it sounds crazy. It sounds like a lot, but it's a pleasure. Honestly, it's a pleasure to do analytics. And I think this represents what our customers, I think, would say as well. To a great degree, what I've tried to do within my team is to reflect what our customers do and try to sort of grow that within Astronomer so that we get firsthand exposure to the joys and the tribulations of what it means to orchestrate a data platform. You know what, Viraj? I'm thinking I should just show you.
Yeah, let's do that instead.
I think it would make a lot more sense, right? It's like let me show you some of the analytics that we've done and how we sort of actually manage that.
I'm expecting a 60-page deck.
No deck, no slides. This is real, right? And like, not just real, right? But everything that I'm showing you is our live production system and our development infrastructure and our Airflow deployments. This is all real. This is what my team does, right? Mm-hmm. So here's a dashboard, for example. I've trimmed it down a little bit, and but this is all real data, and this is being fed live on an hourly or daily basis, depending on the nature of the data. So, this is where we sort of monitor community activity, just what's going out. What's going on out there in the ecosystem. The number of downloads just last month, I think we're over 10 million downloads of Airflow, which is crazy. What was it that, hey, Viraj, you're the founder of the company, right? What was it when we started?
I don't even remember. It wasn't even a top level Apache project, so it wasn't worth keeping track of. Long ways to say.
Yeah, that's right. Well, I mean, even just a year and a half ago, a couple of years ago, it was less than 1 million, right? So
wow.
So yeah, up to 10 million. But here's what I want to focus on. Here's a little chart. We've launched just a new cloud service, right? And it's still getting going, but we're already up to a couple of thousand users, which is really awesome. And I want to be able to enable the operations team to say, well, in this new cloud service that Astronomer has created, what do we think is going to happen over the next few months so we can make sure that everything is sort of being provisioned correctly so we can manage the load. So I asked Marian, who's one of my data scientists, to create this chart, which she did. And I said, I'd also love to see a prediction of what's going to happen over the next few months. So she added that as well, a very simple time series fit. And there it is. So we're predicting, going out a few months, 2,000, 3,000, 4,000, and so on. Everything that I'm showing you is real, right? This is data that is sourced from our production system. It is data that comes from that cloud service that we're reading in on a daily basis to see the count of users. We have to filter out our own internal users, so we actually match it up, I think, to some of our Salesforce accounts, so we can make sure we know who's a real customer, who's an internal user. So a couple of different ingests, obviously the data transformation we do on top of that, and then a little bit of Python code to do the time series fitting. I asked for that. I came up with this idea of doing this simple chart and prediction in the morning. Marian had this running operationally, lights out, by the afternoon, right? So I think it was the next day that it actually went into production because we need to do code reviews. There's a human element to this, of course. But really that whole process of idea to ingest to transformation to predictive analytics and actually running that on a schedule with all of the data dependencies taken care of literally was just in a matter of hours. So let me talk a little bit about how we did that, right? So if you're not familiar with Airflow, this is an Airflow DAG, directed acyclic graph, a pipeline, I think is a simpler word. That's what we should call it. This is a very simple pipeline just to illustrate this case, right? So it's running you can see this gray here is a Snowflake operator. So this is running some Snowflake queries. It's creating some basic ingest tables. It's joining them together. This pink thing here is the Python operator. This is running Marian's prediction code. So pretty simple. This runs on, I think, a daily schedule. If I go here to this grid view, you can see these tasks now, but running every single day. So here's today's run, and that seems to have been successful. I actually had a couple of problematic runs here, but really easy for me to dig into those, take a look at the logs, maybe clear these out, have them run again. Airflow's smart enough that, as long as you follow the rules, it can actually go back and backfill that and rerun that task and say, oh, I'm not just rerunning this task, I'm running this task for October 10th. And so it'll make sure to get the data right and not stomp over the data from the preceding or the next days. So that's pretty standard Airflow DAG. You can take a look at the code here. Not too bad. Here's the prediction. There's just some Python. Again, Airflow runs configuration as code, right? So you actually write your schedule and you write your pipeline as Python code. Here's the Snowflake operators running some SQL. You have to understand a little bit about the Airflow world to do this and the way we chain together operators and so on. It's not too bad. 10 million downloads can't be wrong. It's fairly easy to get this working. This is actually just one of many DAGs that we run in this is our development system. We've got a corresponding production system as well. Here are all the different DAGs that we run. And some of these can actually get pretty complex. I tend to, my developers will spend some time in here if things go wrong, being able to track down just like I did and rerun things. I don't spend a lot of time in here. I might come in here every so often just to see how many DAGs have been running in the last few hours, get a sense of the health of those. Seems like, we had a couple of failures a while ago, but this looks pretty good. The number of task runs. We run about 1 million tasks a month, so it's quite a lot. 1 million a month, yeah. So it's good to get this sort of holistic view. And also, look, there's an underlying cluster here that does sort of auto scaling, make sure that I can run all these jobs in a scalable way and not have to worry too much about the infrastructure. But if I want to, I can come in here and just see if that looks healthy and so on. I have to confess, Viraj, I never spend that much time in here because, I'm not just saying this, it really does run pretty much lights out, but, certainly my data architect will come in here from time to time if things are not looking healthy and make sure, and it's very easy to use some of our lineage capabilities, which I'll show you in a second, sort of say, well, this one's failing because of this upstream task, and I'll find out who the owner is and get them to fix it. Yeah. We also run our sort of machine learning workflows in here as well. Here's one. A set of DAGs that are training a model, storing that, then using that to run a series of validation tests. And then if the model is better, we swap that out. All the standard things you'd expect from MLOps, all controlled from the Airflow scheduler, and all overseen by the Astro orchestration layer. Yeah. And here's some statistics about our machine learning deployment as well. Okay. So this is really cool, right? So Marion is able to construct this fairly simple Python code, submit that through our CI/CD process. It automatically gets deployed into dev or into production. It's actually very easy with Airflow and with some of the utilities that we've created on it in the orchestration platform to essentially just be checking things into GitHub, and we'll take care of the process of promoting it from your development infrastructure to your production infrastructure and so on. You can even target certain worker queues. So for example, if we're running sort of a particularly intense model that's going to use a bunch of memory, we can say, let's use a different worker queue within the cluster that is sized appropriately or separated out and that can scale down to 0 or scale up as requirements. So that's all great. As I mentioned earlier, though, once we've built that infrastructure, right, we really want to open it up to the rest of the organization. Now, Snowflake makes this easy, right? Because it's high powered, it's easy to scale it. You don't have to worry about how you size this. You just add a new warehouse. You can control the compute. The permission structure is very easy. But in order to sort of run operational pipelines on top of that, right, that's where Airflow and Astro, the platform, comes in. How do we open this up? I don't know necessarily if everybody at Astronomer, even some of our more advanced data scientists, are going to be super comfortable sort of having to learn some of these constructs here that Marion's very used to doing.
I think the important thing here, especially as we think about it, is if you're an open source Airflow user, this is just Airflow. We give you that nice control plane to give you some of those statistics on Airflow and provide it as a managed service. But there's nothing in here that I see in your DAG that makes it so this wouldn't work on an open source instance of Airflow. It is very true to the open source spec. And we have day one support
That's
for new Airflow versions.
That's right. That's an article of faith for us, right? It has to be compatible with open source Airflow, and then also making sure that we can very easily bring in the latest version of those as new features are introduced and run those. I mean, it can be challenging, of course, to upgrade, especially in a production environment, a complex open source platform like Airflow. Astro is fully compatible, fully with open source, but also just makes that upgrade process a lot easier.
Circling back to what you were saying earlier is this idea of idea in the morning and then dashboard, even in dev by noon. I've been using Airflow for upwards of half a decade, and that is very hard to do, right? It's very, especially if you're just running the open source, getting something from idea to a pipeline in just a matter of hours isn't trivial. How do folks on your team kind of do that?
Well, really, these days, the way that we do it is we have constructed, first of all, Astro makes this a lot easier because it's, Astronomer as an organization has produced like a command line interface for building, executing, testing, and deploying these pipelines and pushing them up into your Airflow deployment. There's all the stuff that I just showed you around the observability here, so you can see what's going on in your system. That definitely adds a great deal of utility. We've also created our own internal utilities. That means that the data scientists themselves can construct their Python code and their SQL code, and that can be sort of wrangled together to produce a DAG. There are lots of open source frameworks out there, as well as homegrown systems that our customers have produced that allow you essentially to say, well, data scientists, you just keep on doing what you're doing in Python or in SQL or whatever, and then we'll wrap that up into a DAG, right? A lot of that can be automated. That's part of the virtues of having a very open framework like this, that you can construct these DAGs from the raw elements of what the data scientist does, right? And so there are open source frameworks for doing that. What we've tried to do at Astronomer is to learn from those and try and build some of those ourselves. So there's an SDK that we've created that makes it a lot easier to build DAGs without having to learn a lot of the Airflow primitives. And we've even created a notebooks interface around that SDK so that you're almost entirely ignorant of the fact that Airflow is running in the background. So let me show you that. So here's the notebooks interface, right? Think of this as sort of notebooks inspired. It's really a mechanism by which a data scientist can take her SQL code or Python code, which may have been developed somewhere else, right? This might be in Hex or DeepNote or Jupyter Notebooks, or it might have been created in VS Code. But copy that in here, sort of make sure this runs, right? There's a list of connections here that mirror the connections that are in your production environment because Astro owns those. Astro and Airflow owns those. And so because this notebook is integrated into that, it's really beautiful because it means that your data scientist can test her code against the same connections that are going to be running in your development and production environment. It really narrows down that gap between what happens in development and what happens in a production system, right? It's almost the same system. So here I'm just running it. Yep, looks good, right? Didn't get any errors. It produced the right results. Here's some SQL that I'm running. This is the same DAG, by the way, that Mariam was producing here, right? I mean, it's really the same thing. You're actually going to see a version of this graph coming out of the other end of it that looks rather familiar. Here it is, right?
Yeah.
But the way that I created this is not by writing any of that Python rubric, that boilerplate, but just executing these cells. But I'm still doing the same things. I'm creating those core ingest tables. I'm joining them together. I'm running my prediction code at the end of it. I actually do another thing here. I'm actually storing this back into the Snowflake database. Now, look, there's a couple of really cool things here. First of all, right, I'm really just running SQL code, right? Here's our calendar object that we have in the warehouse, and I'm just creating a sort of a truncated, simplified version of that, and then I'm joining it to my counts of user counts. Notice this sort of stuff where I actually refer to upstream cells like create all days, creating that calendar, right? And so these SQL and Python cells can refer to each other, which is how the DAG is inferred from that code. And it means I don't have to worry about like, well, is this a data frame? Is it a view? Is it a table? Is it a Spark data? It just all gets taken care of. So here, in fact, right in my prediction code, very simple time series, as I mentioned, I'm referring to join counts and days, which is that upstream cell that I run my SQL in. That's pretty cool, right?
Yeah.
And Conversely, once I've run that, I can sort of return that as a new data frame, and I can even essentially select from that data frame the prediction from the joins and so on. And so I can treat this really as a data frame, and then that will actually get stored back in the database. And that's what Marion's report is running on, right?
How is this actually run and source controlled? Is it like using Papermill and Jupyter notebooks? Like what is it kind of behind the scenes?
Yeah. So what's actually happening is as we're typing in these cells, this DAG is getting constructed, and hey presto, boom, here is the Python code, very similar to what Marion wrote. It actually is different. I'll get to that in a second. But basically, this is an Airflow DAG that has been constructed out of these cells. Even the scheduling, right? I can specify my scheduling here, just like I'm filling out a meeting invite. And this will be reflected in the code. Here's the schedule now expressed in sort of the mysterious cron language that I've never bothered to learn, and I don't have to because I've got the notebooks interface to do it for me. So the Python DAG is being constructed in the background, and then what I can actually do is I can actually commit this straight into source control from this interface. I don't actually have this configured right now, but I can actually just check this in. It'll do a quick diff, and then it'll be running in my production environment. Wow. So all that Marion has to do, right, is make sure her code works, test out, make sure the dependencies are there, verify that this looks about right, hit commit, and now it's running in dev and production. It's really that enabled her to have such a quick turnaround time. And then as soon as the code review is done, we actually automatically flip from your Snowflake dev warehouse, your Snowflake dev database into your production database. All of that happens without any further input from Marion, apart from just approving the code reviews or getting those done. All of that sort of happens behind the scenes.
Yeah. I'm smiling because I remember the first time you were talking to me about this, you are contrasting it with your experience of trying to run Jupyter notebooks in production, and just how different the idea of actually getting code out of notebooks is, and just source controlling that versus paper milling a couple of Jupyter notebooks.
Yeah, and there are lots of horror stories about trying to get that to work right. I mean, you can Google that, and don't need me to tell you that. But I think the reason why I say notebook inspired, right, is this is fundamentally different in some ways from a standard notebook, right? There is some level of cell independence here, and also cell interdependence in the way that I was talking about before. But we've constructed this in such a way that it gently and politely coerces you to sort of create that sort of task isolation, which makes a lot of sense in an operational world, in an Airflow world. It really allows the data scientist and the ops engineer to be sort of talking the same language, and to create an interface that is essentially like filling out a form for your code that maps well to the operational world. Everybody listening here, Viraj is actually in charge of our registry, right? Which is where we provide links to integrations with, I don't know, pretty much everything in the modern data stack. So some of the libraries that I was using before, including the provider that has been built for Snowflake, comes from this registry. It's really easy to go here and basically pip install anything you like, or actually just add it to the list of requirements in your notebook. And so one of the virtues of a platform like Airflow, which has such broad adoption, is that connectors to upstream technologies like MLflow, for example, or downstream technologies like Snowflake, Fivetran, and so on, are just there, and you don't have to worry about that.
Yeah.
In particular with the SDK, right, which I haven't really emphasized so far, but is running behind the scenes here. You'll see here, I really am just writing Python functions, and I'm just decorating. I'm adding these decorators that essentially say, hey, treat this as a producer of a data frame, give it a task ID, boom, Airflow will take care of the rest. And this is a DAG, but really just looks like a sequence of SQL statements and Python functions. One of the advantages of doing this, right, obviously, is you get to operationalize these things, but also we're listening in on what all of these pipelines are doing and understand the relationships between the data sets that are being created. So we have a virtuous cycle that goes on here where, because we are monitoring all of the pipelines and the relationships between them, and then the tasks and the relationship between those, we have a complete map of your data ecosystem. So I want to show you here exactly what that looks like. I mentioned that calendar object that was at the root of Marion's pipeline, right? There it is. You can see it actually has a lot of dependencies coming out here in the rest of our the rest of our data warehouse. This is actually a map of every single object in our dev data warehouse and how they relate to each other. And all of this is being gleaned and maintained without any additional work from the team. We are just listening in on Snowflake queries, on Python functions, on ingest routines, and being able to map all those things together because we control all of those pipelines and because we have great integrations with platforms like Snowflake, Snowflake being one of the contributors to this lineage movement, right?
I'm gonna make you say something again, just because I think it's the coolest piece. Because in customers that I've talked to before we started heavily investing in lineage, what I would hear is, yeah, we have some lineage tools, but they all require users to change their code or to take action for that to send data to it. And because of that, they're not very helpful because they give you partial lineage, which is almost worse than no lineage at all. So how do we power those graphs? I need you to say it one more time.
Yeah, I mean, think of it as by adopting an open standard, open lineage, and by having essentially listeners that are aware of the execution of each of the tasks in each of these graphs, we can do things like be able to analyze the SQL code that's been written or analyze the Python code, be able to say, this data set was created at this point by this person in this pipeline from these two input data sets. We can even listen for metadata, right? So for example, you see here, this is actually the lineage for that particular chart that I was showing you. So that particular pipeline that I was showing you, you can see here the metadata, the comments, the data types of each individual data set. Even more than that, I can click on this one. You actually see that Python code that was being executed. That gets collected by one of these listeners in the background without addition. You literally do not have to add anything in your code. Airflow and Astro are just running this for you behind the scenes. And so I can see here that, this took a little longer to run on one time than it did in others. And I can actually see differences. If you look here, you can see certain data sets up top are flashing in and out. And those are the ones that change between those two runs. So I can dig into this to see why the time might have changed or why an error might have been introduced. So this is a great way of being able to debug and looking over the history of runs and see what changed in the upstream data sets, right? Here, in fact, 2 fields were introduced. Those are being used in a computation down here. We're even integrated with GitHub so that we can see what the difference was here at that point in the change in that pipeline, right? So we're offering this complete lineage graph of your data ecosystem, but not just a 2-dimensional map, but adding the extra dimension of time so that we can see how the pipelines change over time and use that for debugging and also understanding the ramifications of any of the code that you're changing, and also as a searchable map of your data ecosystem.
Yeah, searchable network of data sets almost.
That's exactly what it is. Yeah.
Well, Stephen, thank you so much for walking us through this. If anybody wants to learn more about Astro, Airflow, Lineage, or anything else of the sort, please feel free to reach out to us, and we'd be happy to chat. Thanks, everyone.
Stepped up your game! I've been using Snowpark, silly! It lets you build snowballs with confidence by removing data security and compliance barriers to production with consistent, enterprise-grade governance controls. Pretty cool, right?
Wait, what?
Frosty gets his own song. Why aren't we singing about Snowpark? The easy way to production for Python! Using pre-installed packages and automated dependency management and secure processing. How do we make that rhyme? Oh yeah, speed! Woo! I built this myself. Nothing could go wrong. Oh no! Ah!
You didn't use Snowflake Snowpark. It's the only way to go. Woohoo! I'm going so much further. Eat my snow!